these assets together. So probably I need to now show the figure. Yeah, okay, thank you. Okay. So yeah, so these were my industry partners, and yeah, that's I was working with Professor Ioannis over here. Okay, so when we talk about information requirements, I define information requirements as the data and information needs necessary to create, operate, and maintain a functional and useful replica of a physical system. That's information requirements for digital twin. It matters because right data, right time, and right format can make you help right decisions. So that's a simple bit of it. So we saw this fragmentation problem in national highways, and we particularly proposed that, okay, we see that there are multiple assets which are called as products, or we have, as I was telling, road markings, roadside vegetation, traffic signs. Next, we have some decision stages. Okay, so for each of these assets particularly, we have to think about how to collect data for the ambiguity. Either we kind of select the survey technology, then we kind of make decisions on the instances where they go wrong. For example, for potholes, how to collect data, how to find out the potholes, and what to do about them at the end. So these are some decision making steps, which are stages. Next are each of these decisions is affected by many factors. We will see how I came up with those factors, and each of these factors finally have a bin of information requirements. So with this kind of a broad framework in mind, we also know about that there are multiple components of information requirements. For example, asset type and scope, what asset is there, which life cycle stage is being done. I particularly focused on the maintenance part. Data categories could be geometric, condition-based, performance, etc. There can be multiple level of details or granularity involved, and also the update frequency, how frequent we want to monitor this. Okay, so yeah. So finally, we came up with this kind of model, which kind of has multiple parts to it. So if you see, the assets are the assets from the road environment. Then we have multiple stages, factors, and as I was telling, each of the factors will have information requirements. With the information requirements, we will have kind of a timestamp data where we can do either forensics or predictions based on this information requirement. Currently, how the national highways works in silos is like this. One asset will have a cluster of decision-making points, factors, and information requirements. Obviously, they don't know what it is, but somehow the decisions are being made very subjectively. So this framework tells us that there are, from the information requirement pools, we cannot just make decision for one asset, but it can be linked to multiple assets. So the same information need not be collected again and again, and we can go very systematically about it. So how did we came up with this, and how we go about the information requirements is something which we define in this kind of framework. First is the objective and scope definition, what we want to do with these information requirements. Second is stakeholder engagement. Every team has different types of stakeholders which are involved in kind of maintaining their assets. For example, a vegetation team will have a vegetation maintenance contractor, the cutting, the clearance team, as well as the decision-making team at the planning level. So we kind of interacted with them, had workshops, had feedback loops. Then we did a current system analysis. So we mapped a current BPMN, which is business process modeling and notation. I will show you with the help of an example how we did that. That was how the current process and the map, to map the current process, how is it going. Then finally, we kind of were able to gather the requirements which exist and which don't exist from literature, from multiple documents, and from the existing processes. We created a prototype to validate this, and we document it in the form of publications and papers. So let's just see about a case study, how we kind of went about these information requirements. And yeah, this was recently also published. So we see that I will take case of overgrowth vegetation, where in the UK there are multiple casualties, but it is not very highlighted, part. There are deaths, there are casualties, but it is a contributory factor, but people don't take it very seriously. It contributes to obstructing driver's view, it contributes to obstructing road signs. It also contributes to damaging infrastructure. So with all this, we went to the National Highways team, we talked about it, and we kind of mapped how they go about the vegetation. So this is the BPMN I was talking about. So we have a program manager, a pavement inspector, and a road repair contractor, which kinds of clears the vegetation. The pavement inspectors does the visual condition survey, and the program manager, sends a task list to the pavement inspector and also creates the plan for the vegetation control. So the process is there. This is just to map the existing process. There are multiple requirements. So when we went through the whole 6 steps of the methodology, we were able to identify 3 decision-making points: which technology to select for the survey, what are the overgrowth instance of vegetation, and finally how to remove that. So this is the final graph that was generated. So if you see that there are n number of factors, and only I think 5 or 6 factors were available from the BPMN, in which they use in the existing process of vegetation requirements. So the stages, factors, and the information requirements were identified in 3 stages. This is for the vegetation survey technology selection. We have factors like cost, processing efficiency, operational efficiency, and each of these factors have multiple information requirements that helps us to make some decisions. This is again for overgrowth vegetation instances. For example, we need what type of vegetation is there, what is the location of overgrowth, what is the size and dimension of overgrowth, and maybe also the growth rate in some cases, multiple other project data. And finally, the control strategy also needs what type of cost will be there, what is the environment impact, etc. So you see that just a small BPMN is not sufficient. There is a lot more information requirements that could be gathered and be sought. So I'll just show you the use case. From this information requirement, we developed a prototype where we wanted to take care of roadside vegetation. So we applied a simple concept that, okay, we will have a vegetation-free envelope zone, which we demarcated with the help of a road marking. So the road marking is our one side of this vegetation-free envelope, and that should be it. So we went ahead with a very basic technology, a mobile phone camera. We collected a video of a stretch, and then we segregated the frames where this overgrowth was available. We demarcated the roadside marking, and finally we were able to see what type of vegetation was coming onto the road. So because it was just captured through camera, there was no calibration, there was no ground truth available. We were able to just tell that, okay, if there is 100% of road width, around 44% of road width is there. Similarly, we went ahead with the 3D technology. We had a stretch, we have our data set called Cam Highways dataset, and finally here we were able to extract the 3D point cloud of the roadside vegetation which was there. So the difference between the 2 technologies is that one technology is quite basic. It does not give you the 3D perception. It does not give you exactly where those instances are. The other one gives you the vegetation density, the 3D perspective, etc. So yeah, so this was just one use case of this one. The information requirements could be similar could be used for multiple other assets. So finally, concluding my presentation, the information requirements we see are the backbone of digital twin or any digital twin. The foundation data model which we have explored can be used for multiple use cases for the road assets with existing information pool. We have shown just one, and the methodology proposed for establishing information requirements becomes critical if there are multiple stakeholders and decision variables involved. So with that, I would like to acknowledge my